Hello, everyone. I am Dion Cook from Avixa, and welcome to High Performance KVM, the key to flexible, efficient workflows, presented by Paul Mott. This webinar is brought to you by our sponsor today, Raritan. But before I hand the presentation over to Paul, there are a couple of housekeeping items that I must address first. For you CTS holders, today's live webinar qualifies for a half renewal unit for the CTS, but none for the CTSD nor the I. Please allow up to 7 business days for those to appear on your transcript. If you have any issues, please email the webinar team directly at webinars@avixa.org. Today's webinar should last between 45 and 60 minutes, and all attendees have been placed on mute. If you have any questions during our presentation, please enter them into the Q&A window so today's moderator can address it at the end of the presentation. To access the Q&A window, move your cursor towards the bottom of the live stream video box, locate the Q&A icon, and type away. Just please be very mindful that there is a separate menu for the chat and to not put your questions there. You will have access to this recorded webinar at avixa.org/webinars within 5 to 7 business days. And that's all from Avixa for now. Paul, please take it away. Paul, I believe you're on mute.
Thanks, Dan. Appreciate that. Thanks, everybody. So as Dion alluded to at the beginning here, we're going to talk a little bit about high performance KVM and how that will certainly impact your lives and end users' lives as well. So just to give a quick introduction to myself, my name is Paul Mott again. I'm the Director of Product Management for the KVM and remote access business of the Raritan brand. So those of you who may also do business with the Legrand AV division, we're slightly different. We are the data center or IT division, but you know, as our markets continue to converge here, I'm sure that some of you may have worked with both divisions. So I've actually been with Legrand for 13 years now. I previously came from the Legrand AV division and then transitioned over to the data center division. Have experience in lots of different types of AV technologies, signals, signal routing, networking, and all kinds of different AV infrastructure, as well as data center infrastructure. So happy to be with you guys. Thank you again for taking some time out of your day, or maybe sitting down during your lunch break to listen a little bit more about high performance KVM and earn some of those credits while you're at it. Okay, as a quick overview of the agenda, we're going to just have a refresher and an intro into KVM, high performance KVM. A lot of you guys may already be familiar with this, but it's always good just in case. We're going to talk a little bit about how high performance KVM is used in the market today by our end users. And then we're going to talk about the evolution of the market, kind of where we see things are going, how users are using this technology, and what we should expect to see next. Then we'll spend a little bit of time on the Raritan high performance KVM products for AV applications, and how we're a little bit different in the market than maybe some of the traditional products out there. And then we'll wrap things up, and we'll certainly do a Q&A. If you guys have any questions, feel free to enter those in under the QA section, as Dion mentioned. Okay, so just a quick refresher. Most people know in this business know what KVM is. They've maybe installed KVM or have used KVM in the past. But for those who might be new to the industry, maybe haven't used a KVM switch or installed one before, it really is an acronym. It stands for keyboard, video, mouse. And really, at its simplest form, it's a device that allows the connection to multiple computers and allows the use of just one keyboard, mouse, and monitor, sometimes multiple monitors, to access all of those different computer sources very efficiently and conveniently. Now, if we look at kind of the history of KVM, it's fairly interesting. It really started way back when in the 80s. when all signals were analog. We didn't have to worry about any digital switching or anything of that nature. So we had these very unsophisticated rotary dial style KVM. If there's any old timers on the webinar, you'll know what I'm talking about. These things were pretty prevalent back in the day. I remember I used to use one back in the 90s, just switching between different computers. I actually had a 4-port one, so I was a little bit more sophisticated. But I had a 4-port rotary dial switch to switch between all my different computers and servers that I had at my desk. So very simple technology, literally just a bunch of wires in a box, and you'd flip a switch and it would connect you from one computer to the other, and you could essentially use your keyboard and mouse like you would without having to attach a separate monitor, a separate keyboard, set of keyboard mice to all the individual machines. Now, when we move into the 90s, this is when kind of the matrix style KVM came into the picture. Now, the reason for this was, as the dawn of the personal computer age started, there was also a requirement from a business standpoint to start housing more information on servers. So that meant more infrastructure to manage. That meant there needed to be a way to be able to kind of solve that challenge. Like, what do I do if I have 100 servers? Obviously, I'm not going to buy 100 monitors and mice and keyboard and plug these things in all over the place where all my computers are stored. So that really gave birth to the matrix style KVM. It could be a single user, it could be multiple users. It's really all cable based. So, a combination of maybe, proprietary, DB25 style connectors that get connected up to this, and what have you. And this was very popular for a very long time in the 90s. And some of these are actually still deployed today, believe it or not, on legacy systems. I've seen some out there in the wild. It's kind of shocking, but they're out there. Moving into 2000, this is where, really the information age boom started, and just the requirement for more devices on the network, really high density server cabinets, started to come into the picture. Data centers started to scale massively, as the dot-com boom happened, and you had all of these different businesses and websites and companies just adopting more technology. So that means they needed a better solution to manage all of those sources. And that's where IP-KVM came into play. And really what IP-KVM is, it's kind of a departure from a localized style cable KVM that might be only accessible just to the users really that are around the equipment. And it allowed remote users to be able to connect up to the internet, and then down to their infrastructure, whether it was broadcast or IT infrastructure, or AV or IT. They could be able to do that, using basically just a web browser, or a laptop, on a laptop or on a desktop, regardless of where they were. So it was really kind of a watershed moment for the KVM industry, moving things onto the network, allowing users to be able to remotely connect, and just the scale. We went from maybe a handful of computers connected to a KVM switch to dozens or even hundreds of connections per KVM switch or per KVM switch infrastructure. So this is still very much useful today. Raritan was one of the leaders, or still is the leader in this market, and continues to sell this to both the AV market and the data center and IT space as well. Now, as we kind of went from the 2000s into the 2010s, I'm sure all of you guys are very, very familiar with the analog to digital transformation and what happened there. So basically, we had all of this audio and video data that went digital, necessitating the need for really a next generation KVM. And that's where high performance KVM comes into play. Now, it started off simply, but again, as most things do, it scaled very quickly to the point where, now in the market, we have, some of these large scale cabinet-based, KVM switches that can handle really high resolutions or, really low latency. And that's really what the market knows and loves today, and that's what's being installed out there. But as we get into the 2020s, we've started to see a shift, and really it's moving back towards IP KVM and some of the benefits that it brings, and we'll talk a little bit more about that a little bit later in the presentation. So this is kind of just a quick history of KVM for those that weren't aware or maybe forgot. It's really come a long way since 40 years ago with these really old style analog dials to to network connected devices to really high performance style KVM, and then really back again to IP connected devices. So where is KVM used? Number of different types of infrastructure depend on KVM every day. For Raritan, our bread and butter really is in the technology space. So we deal with customers large to small that have a lot of different needs, whether it's a hardware test lab, where maybe they're working on the next generation of processors, motherboards, video cards, any type of electronic device, in some way, shape, or form will likely have a KVM connected to it in the test lab, so they can do a number of tests across hundreds or even thousands of test devices as they're getting ready for the market. Of course, general IT administration, that's where KVM started. I won't belabor that. We've also seen a lot of use in industrial manufacturing. The need to have KVM, or really the need to remove people from certain environments, has really been a boon for KVM in manufacturing. As plants become larger, as manufacturing equipment becomes more sophisticated, there's been more and more of a need for KVM to replace people or allow technicians to be able to remotely monitor, remotely access, and reduce mean time to repair on some of this equipment to make sure that operations continue smoothly. And of course, various types of high density infrastructure, again, more IT focused, and I'm not going to get into that. And on the right hand of this slide, you'll see, this is really going to be the core of the discussion in the upper right hand corner. High performance for broadcast, AV command and control. That's where you guys live and breathe every day, and we'll dive much, much deeper into that. But as a side note, healthcare is also another emerging space, and some of you may get some exposure to that as well, and working with healthcare focused end users. KVM is starting to revolutionize the healthcare industry. We all know that healthcare is a little bit behind on its digital transformation, probably bringing up the rear in that respect. But they're starting to look at KVM to augment some of the things they do, not just in their infrastructure, but in their patient space as well. Maybe an interesting topic for another webinar in the future. Okay, so high performance KVM, really, why is it extremely important to the market? It's really defined by environments that have a need for high resolution, low latency for mission critical tasks. Now, some of you may already have some of these types of install environments, and this is certainly not all of them. There are a number of different types, but air traffic control, broadcast, and military command and control are really three typical scenarios where high performance KVM continues to be sold and continues to be used and appreciated by the end users. And it's really about the ability to first present a tremendous amount of information to the users, being able to control various systems, being able to quickly shift between systems, and be able to react very quickly, right? And as an air traffic control military command, I mean, it's really could be potentially life and death situations. So, the amount of latency is critical. You can't be laggy, you can't misclick something, you have to take action, and you have to consume information and react to it with the utmost importance. And the same thing goes for broadcast. Maybe not life or death situations, but there's certainly a financial impact, right? If something happens and the screen goes blank, that's lost money, right? There's likely going to be some sort of potential financial impact or legal impact if you're not maintaining your systems and operating it to the utmost efficiency. So again, there are numerous types of applications for high performance KVM. And really it's all about being able to access a tremendous amount of data across numerous systems, being able to control those systems, being able to react quickly, and being able to perform all of the tasks that you need to perform in the most efficient way as possible. Now, a couple of other applications on here I didn't mention that kind of are emerging that are certainly out there, things like esports, financial like trading desks, and again, really anywhere where time and resolution are kind of the critical factors at play there. Okay, so what does a typical high performance KVM system look like? It's generally defined by a switch at the center of the screen here and a combination of transmitters connected to your computer sources and receivers connected to displays. Now, some products from different manufacturers can vary. Sometimes you can maybe have multiple displays at every receiver. Maybe you can have multiple target computers at every transmitter. But really what makes all of this work is the switch in between all of them. Now, KVM switches kind of start off as this proprietary technology, but really most KVM switches now really rely, or at least high performance KVMs rely on some type of network fabric. And in most cases now, it's some sort of 10 gigabit network switching type of device. And certainly the switch will have other capabilities and functionality as well. It's not listed here or shown, but there could also be some type of management interface that layers on top of this so that you can provide access privileges to certain users, to certain devices, so they can get to what they can get to and maybe not access what they shouldn't. Now, again, these systems have been around for a while. They're great. Super low latency, high resolution, 4K, some can maybe even do 8K, 4K, 5K, up to 8K. And really it provides all you need from a multi-system access standpoint. Now, of course, there's also some cons to this. Now, just because it uses a kind of network switch backbone doesn't necessarily mean that it's routable or accessible remotely always from the network. In some cases, it can be completely isolated unless you have some sort of remote access accessory or dongle or add-on product that you plug in here. It's not routable, so you can't take the input from like a 4K target computer, route it over a network, and have your receiver in maybe a different floor of a building or a different command and control center. Typically, it's very, very localized. And the reason for that is the high amount of bandwidth that these systems use, That's the trade-off for low latency and super high resolutions. There is some, hardware compression or hardware encoding and decoding that's happening on this, but it's still a tremendous amount of bandwidth. And sometimes you can be limited in the amount of displays that you can connect on your receiver as well. If you need to add more displays, depending on the application, you need to maybe throw more hardware, more equipment at the problem. But very typical type of high performance KVM setup, a switch kind of, a KVM switch is the foundation to this. And then you can scale with transmitters and receivers in your environment as needed. And then once you run out of spots on your KVM switch, you buy another one and then continue to scale as needed. Okay. So how is the market evolving? So, we covered the current high performance KVM and what it can do, but the challenges that are coming are and maybe already even here are posing a problem to kind of the traditional architecture. And really, this is really kind of keyed in on these four areas that I'm going to talk about here. The first being the fact that target sources or target computers, the data that you're trying to access might not always be in the location that where the high performance KVM is. It might be in a different cabinet, might be on a different network, might be in a completely different location. And you might need to be able to access that remotely as well. So meaning you might want to be able to remote in and collaborate with some of the users may want to remotely access and collaborate with some of the on-site personnel, whether it's a sporting event or command and control environment for the military. The need for remote access is becoming absolutely critical, and we hear this from end users all of the time. And on top of that, workflows are becoming more complex. The amount of overlays and data and analytics and really the typical user of a high performance KVM gets bombarded with things they have to do day to day. They have to create tons of different macros. They have to start looking at ways they can automate things so that they can make sure that all of the data that gets presented on all of the different screens is as how it should be, and they can react to it and respond to it the most efficient way possible without fumbling through changing sources and generally just wasting time overall. And of course, last but certainly not least, budgets will continue to be a challenge for everyone, especially in this environment. Who knows what's going to happen with tariffs? And there's just going to be a general need to explore lots of different types of technology to be able to solve all of the challenges that the end users are going to continue to throw at us. Okay, so since we know the market's evolving, where do we think it's going to go? And I'll share a little bit from our perspective, since we get a chance and an opportunity to talk with a lot of end users and integrators and resellers and kind of really a number of different people that influence specification and buying decisions. So, the first bullet shouldn't be a surprise. I think this trend started a very long time ago. Really, once the analog to digital transformation happened in the AV space, it kind of opened the floodgates for the potential for IP-based products to really start to emerge. And you're going to start to see more and more of this, and it's just going to be a continual push to having these two real industries merge together and work in unison. Now, of course, high performance KVM, it's not going to disappear overnight. It's going to continue to be used, but what we think and what we see is, high performance KVM over IP is really going to be kind of the next step in evolution for the KVM market. And really, it's going to live side by side. It's going to help solve some of these challenges that we just talked about. And it's going to be a new way to deploy high performance KVM that expands the possibilities and maybe changes the way end users and integrators like yourself think about how KVM can be used. And of course, right, as costs become more and more of an important issue, right, the need for dedicated niche infrastructure to deploy technology is going to become a challenge. It's going to become questioned. People are going to ask, well, why can't I just put this on my network, right? So high performance KVM infrastructure, again, not going away, but at some point there's going to be a shift to kind of more standard off-the-shelf network switches and a move onto the production network versus having more isolated, cordoned off parts of the network that just operate for a specific function, which is high performance KVM. And then, of course, there's tons of different types of technologies out there for encoding and decoding audio and video. I'm certainly not an expert. I'm sure there's probably a handful of you on here that are. We're going to continue to see this evolve. There's a bunch of different competing formats out there right now. One of the more interesting ones, at least from our standpoint, is JPEG XS. So if there's any interested parties, I'd highly suggest checking that out. There's some interesting work that's going on around there. And what we're starting to hear is that with some of the evolution around these, right, we're gonna see some of these compression technologies really start to compete with some of the legacy technologies used today that drive really our high latency, low latency, high performance KVM infrastructure. And of course, as things start to move more onto the network, as things become kind of more consolidated, there's going to be a lot of different opportunities to adapt KVM to different environments, some of which I talked about, some of which maybe we don't even know about yet. But I'm certain you guys are going to have these end user problems come up, and KVM will always be a very useful tool moving forward, and being able to really make sure that end user workflows in their various types of environments continues to be efficient and continues to evolve along with what they need to get done. Okay, so how does Raritan play in the high performance KVM space, and really what are the differences in our product and kind of how it works? So Raritan has really always been a high performance KVM over IP solution, really going back to some of our earlier IP based products, and then now with our enterprise KX3 KVM switches. I put transmitter and receiver on here just because we call them very different things. Again, we come from more of the technology world versus AV. So these mean kind of different things depending on the audience you're talking to, but hopefully this makes sense. So we have a number of different types of products here. On the transmitter side, again, our KX3 for multiple types of devices, 1080p, that's the max. And then for 4K workflows, we have our KX4-101. That's a single port device that gets connected up to a target computer. On the receiver side, we have two different types of workstations or I should say user stations is what we refer to them as. Now, we work a little bit differently than the rest of the high performance KVM market, in where our user station or our receiver is really built out of the box to be completely customizable. The workspaces can be moved around. We could support up to 4 screens per device. And then we can also link these together, and I'll talk a little bit more about that on a later slide. So the biggest difference that you'll see here is that instead of a proprietary KVM switch that kind of supports all of these different transmitters and receivers, you can use just a standard traditional single gigabit LAN type connection to all of these different devices without having the isolation of a typical high performance KVM system. So that's a huge value right there. Just being able to use potentially existing network infrastructure, not deploy more hardware, huge benefit, and it still works very well. Another huge benefit is just remote access in general. So on a lot of high performance systems, you need to buy some sort of add-on management piece or what have you to be able to enable remote access. All of Raritan's high performance KVM products come with remote access built in. So on the KX3 or KX4 transmitter devices, these can be accessed remotely given the right permissions, regardless of the need of a receiver being part of the equation. So if a user needs to jump on their computer, their laptop to collaborate on something, to just monitor something remotely, that we have the ability to do that with zero additional cost to the system install. And then of course, as these systems can become more complex and you need to secure them, we have our Command Center Secure Gateway that provides kind of a single point of authorization and access to the KVM infrastructure. And it also allows you to do a number of different management activities as well. You can, batch types of jobs for firmware updates, you can do things like certificate management, and a whole host of other types of kind of higher level administration for the high performance KVM install. And just last thing I'd like to note here, right? All of our access to all of our KVM switches or our transmitters, again, uses really highly secured, if needed, compression. It's really military grade. We use FIPS style compression algorithms. So for highly secured military types of environments, we check that box. And then we also have the ability to, ratchet settings up for really high performance environments. So if you need to get the best performance possible, you can adjust the settings, may consume a little bit more bandwidth, but again, compared to some of the other solutions out there, it is a fraction of the bandwidth used. And like I continue to mention, it can be readily used on production networks that exist out there. Okay, so again, some of the benefits, really efficient way to deploy high performance KVM. Doesn't require dedicated switch, can use existing network infrastructure or standard gigabit Ethernet type switches that are pretty ubiquitous out in the market today. Bandwidth is really important when you're running on these production networks. You can't hog up all the bandwidth that might be potentially used for other types of systems and purposes. So again, we have the ability to fine tune that throttle up or down based on the environment, and it's a very nice way to augment some of these potential legacy high performance KVM systems out there. Now, high performance KVM is pretty scalable, but when you move to an IP based solution, you just get even more flexibility and scalability. You're not dependent on standard switches that are really only located in one place. Essentially, wherever there is a network drop, you can connect a target computer or a transmitter, and then wherever you need to put a user workstation, you can connect a user station or receiver device. Again, connect to the network and set up the right permissions, and then the user can start to access all of their high performance KVM infrastructure. And certainly remote access, as that becomes more important, it's just standard on all of the product. No need for any additional devices or add-ons. It comes standard out of the box with every transmitter type device. You can tunnel in, you can do administration without having to even be on site, or like I said, have some other ancillary way of doing that. And what we've seen also is the need for more budget-friendly solutions out there. So high performance, but not a high price. And with this type of IP-based high performance KVMO type system, lower upfront cost if you can use that existing infrastructure. You also don't need any type of point-to-point type extender, which can be prevalent on some of these types of products. Like if you need to set up a workstation in another room, you need to run a fiber drop or an Ethernet drop somewhere. None of that is necessary as long as there's network connectivity. There's no need for any types of KVM extender types of devices. And again, this is all category cable based, so no fiber, no transceivers. You can keep it simple and keep it low cost to meet maybe some of those budget requirements that end users might have. All right, so to kind of just go a little bit deeper on our individual products that kind of make up a high performance KVM system. Again, our DKX4101 on the top here. This is again a single port HDMI based type of product. It has a local console pass through if for whatever reason you need to be, or the user would like to be able to pass through to maybe a local screen, keyboard, wherever the equipment is stored. They have the option, but this is really the fundamental piece to the to the high performance KVM infrastructure. There's also some other interesting things on here. Super fast virtual media, which can be needed in some cases when transmitting files back and forth, especially remotely. We also have terminal block for control. I won't get into all the details there, but you can do a number of different things with the terminal block, whether it's either connected to a remote switch, remote equipment, or potentially to the target device that's being controlled as well. So again, it works completely independent of the receiver. So you do not need a user station or a receiver for this to work. You could literally, once this is on the network, you could open up a laptop, a web browser, start a KVM session directly to the device. And that's a very, very handy tool, especially for the administration of some of these systems, right? Having to roll trucks, getting on site to be able to fix something is not ideal. Once the device is on the network and you have the right permissions, you can just portal right into this, right into the high performance KVM infrastructure, fix what needs to get fixed, and move on with your day. I know a lot of you guys will likely have service contracts, so this is a huge benefit for you guys. And we all know that the AV industry has kind of moved in that direction over the last several years, right? Remote maintenance is key. We talked about the super low bandwidth that our products consume. Again, it's really just a testament to our compression technology that we've been developing over the last 20 years or so at the advent of IP KVM into the marketplace. We continue to evolve that, and we continue to look at new technologies as they emerge. I do want to spend maybe just a few minutes talking about AV automation and an AI-ready system. So we're one of the only manufacturers on the market that actually has a KVM client SDK. So what does that mean? It's a software development kit that can basically programmatically access a target computer, perform a number of different functions like keyboard keystrokes, mouse clicks in various positions on the screen, screen capture, screen recording. So it's a extremely useful tool that you can layer on top of the high performance KVM infrastructure that allows the potential for AV automation. So taking maybe very complex workflows that may not necessarily be possible with maybe some of the macros and some of the tools that are out there today, and allows you to completely automate those. Now, we also know that AI is a big buzzword, and everybody's talking about it. We've all seen the headlines and how much growth there is in the market and data centers, what have you. But what's interesting is at the edge, right, where maybe you don't have a large language model where you need an entire data center to process request for, I don't know, some sort of weird AI generated image. There's a huge movement in deploying AI, smaller, more compact models at the edge to be able to perform a number of different tasks across a number of different industries. Right? AV is not going to be any different than say industrial manufacturing or IT. There's going to be opportunities out there, and if you have programming experience and you have developers, within maybe your shop or your company, this is a very useful tool. We've opened it up; it's publicly available. You can download this on our KX4 support site, and we feel that this is going to be kind of the next revolution in KVM, right? Not just having that direct hardware access to a target, but having the ability to automate tasks, and then eventually, when AI is ready, being able to kind of unleash that on various high performance KVM workflows that we know that are out there today and are becoming increasingly complex, right? We know that fewer people are going to have to do more moving forward, And this is going to be a very, very interesting tool for a number of different industries to utilize. So if you're a nerd like I am and you want to see what the possibilities are, definitely check that out. Now, on the receiver side of things, we have our DKX4 enhanced user station. This is essentially like a thin client, as most of these receivers are. Our particular flavor is an AMD Ryzen powered device with Radeon graphics acceleration. So that allows us 4 video outputs per device, and it is 4K 60 capable. It's very compact. The image might not do it justice, but this is like one of those small, high-performance desktop PCs that you may have seen out there today. So incredibly useful. It comes standard with a VESA mount, so you can mount it behind monitors. And it has some kind of interesting characteristics to it. The first one is that it's extremely scalable, meaning you can link 2 devices together, use 1 set of displays, 1 keyboard, 1 mouse, and you can basically scale this depending on however many displays that you might have, depending on the application. Since it's all software-based, it just works. You plug them together, click a few settings on the primary device, and now you can essentially just continue to expand your work environment across however many displays that you need to. Now, I will say that it will have some limitations depending on the sources, right? You're not going to be able to just kind of infinitely decode 4K 60 streams. So there are some limitations on that, but some of that is documented out in our support documentation if you're interested in more. Another interesting functionality of our user station or our receiver is it has completely customizable workspaces. So it doesn't necessarily have kind of some of the static layouts that that we know are part of some of these high performance KVM systems. It allows complete customization and saving of workspaces, and then you can use hotkeys depending on your workflow, depending on the type of system that's being used, to very quickly switch between all of the different computers that you might be interfacing with, so that you can really consume a tremendous amount of data and work on many different tasks at once, all through one single interface, through one device. So that's what makes up kind of the foundation of our high performance KVM system. I know, I'm sorry, it's not more complex. It's 2 devices, and then you can bring your own network switch, and once everything's connected, you're basically ready to go. Okay, so just a couple of quick takeaways before we get into Q&A, right? We know the high performance KVM market isn't going anywhere. There will continue to be a need to have very low latency, very high resolution, direct computer access to be able to complete a number of different tasks across a number of different industries. But high performance KVM is going to evolve. It's going to become more IP connected, and that's going to ultimately help you guys, help the end users. There's going to be problems out there that just aren't able to be solved using an isolated high performance KVM. There's going to be remote access that becomes increasingly important to end users, right? The ability to monitor and maintain some of these environments remotely, right? As certain groups of people might get consolidated or moved around, right? You may not always have the right people on site all of the time needed to support some of these. And of course, for you guys, it gives you an opportunity to continue to support your service level agreements that you might have with some of your end users. Again, high performance KVM currently runs on 10 gigabit networks, but it doesn't have to. It can run on single gigabit networks, standard production networks that are already out there today. As long as there's spots on a network switch, you can start to deploy high performance KVM over IP adjacent to or alongside of some of the existing high performance KVM. And high performance KVM will continue to allow for, just an increasing amount of systems that we continue to see get thrown at us day to day on some of these environments. It's going to allow, right, especially when they become more IP enabled, it'll allow for increased collaboration. It'll allow for people to remote in that aren't necessarily on site. And it's going to reduce the amount of potential hardware that you need and allow you to scale more efficiently as you deploy these systems. So that's all I had for my presentation. I hope that this was informative, that this got you guys thinking a little bit about the potential options out there in the market, and how you can deploy high performance KVM in your day-to-day lives. So with that, I will open it up to questions. Let me just over here. So the first question I have, does the KVM system need to be on its own VLAN? Great question. It does not. So the Raritan high performance KVM is completely routable. So it doesn't need to be isolated, doesn't need to be on its own separate network. It can run on a standard 1 gigabit production network without having to be isolated, without having to have, like I said, that dedicated 10 gigabit KVM switch infrastructure to be there. Message or question from Andy. So could you start with just one transmitter device connected to one source computer and then use a laptop and web browser to access that computer across an existing network? Yes, absolutely, Andy. It's good to see you. I think we've spoken in the past, so it's good to see that that you're on. Yes, absolutely. You do not necessarily need a receiver device. As long as the transmitter or the KVM switch is in place, it gets encoded and it can be accessed not only from a receiver or user station device, but it can be also accessed on a laptop, on a desktop, anywhere that a user has network access. And I would just say, with a lot of the advancements in a lot of our laptops and desktops today, I mean, we have extremely powerful devices from just 5-10 years ago. So a lot of the decode can happen, and you're not losing really any any resolution, and it continues to be low latency. And that's all I had for the open questions. I'm happy to hang on here for a few more minutes if anyone's still typing. But again, thank you guys very much. I hope you got a little something out of this and how high performance KVM is starting to evolve. And we're looking forward to participating in maybe some more of these webinars and helping you guys get some more credits in the near future.
Okay, I think that's it. Paul, thank you so much. And I'd like to thank all of our attendees for joining us on today's webinar, High Performance KVM, the key to flexible, efficient workflows. This recording will be available on the Avixa website here at avixa.org/webinars within about 5 to 7 business days. And then your 0.5 renewal unit will be applied to your transcripts within those 7 days as well. If you have any trouble with this, please contact Avixa's webinar team directly. We're at webinars@avixa.org. An important side note for CTS holders, if you registered for our presentation with an email address other than what's on file for you, you won't get credit for attending. That can be fixed in the background, however. So what you need to do is email membership@avixa.org and let your account rep know that you used the wrong email address when you registered, and we'll get it fixed for you on the back end. And I want to take the time out to thank Raritan, and a huge thank you to Paul for helping us to understand what's the key to flexible and efficient workflows using KVM. And be sure to continue this conversation and connections made today by joining the Avixa Exchange. It's an AV provider directory in year-round community where you can grow your network and stay updated on current industry trends. So we hope you've enjoyed our presentation today. I want to thank everyone for attending again, and let's make it a great day, everyone.